Hi, Geometry. This is lesson 3, and we're going to learn our very first construction. This is construction number 1, perpendicular bisector. Construction number 1, and this is perpendicular bisector. And we're going to be learning about 9 different constructions. So this would be our first one. So perpendicular is sometimes abbreviated with an upside down T, and bisector I abbreviate with a BIS. So in my notes, you'll find that I write this perpendicular bisector. If I see this upside down T, I actually say the word perpendicular, and when I see BIS, I say the word bisector. So let's begin by doing this construction. We first need to create a segment on our page. So start with a point A, and maybe about an inch over, inch and a half over, I want you to draw point B. Grab your straight edge that you've been working with and connect A to B. We're going to be needing our compass now for the next 2 steps. So in the perpendicular bisector construction, leave some space because we're basically making our 2 circles that we made in lesson 1 and 2. We're going to be making that same diagram again. So leave some space. So step 1, we are going to construct circle A with radius AB. So I'm telling this to you how illustrative mathematics approaches it. Technically, your radius just has to be set to something more than halfway, and this construction works. So let's do what it says. My center is going to be A. This is circle A. My radius is going to be the length of A to B. So I'm going to get my compass, and I'm going to move my pencil so that it's on B. So I need to make this a little longer. That is now going to be my pointer on A for circle A. And I'm going to draw my circle, and it should go through B because I set my radius to AB. So someday I'll get my circle on there. So now we're going to do step 2. We're going to construct a second circle. This one's going to be circle B. So my center is going to be on B. And my radius is going to be the same. So now I'm going to put my pointer on B. If your compass has moved, you're going to have to reset it. Mine has not. One nice thing about a dial compass is it holds your radii really well, or your radius really well. So I'm going to put my pointer on B, my pencil on A, and I'm going to draw a circle again. This is a very familiar diagram. We did it in lesson 2 as well. So now your circles intersect in 2 places. So step 3, we're going to mark and label intersection points. So in this case, I'm going to label the one at the top C, and I'm going to label this one D, although the letters aren't that important. So our very last step, our step 4, is to use a straight edge and connect the intersection points. In this case, it's C and D. So let's grab our straight edge. Let's line up C and D, and you can connect them. You can stop at C and D, or you can go on. Oops, that was not very good. I'm going to put an arrow at the top. I'm going to go ahead and do a line here. So, because I want to talk about just how we label lines versus segments. So on my diagram right now, I have segment AB because it stops at A and stops at B. And I have line CD because I have arrows on the end. So in this diagram, what I've just created is the perpendicular bisector of AB. So line CD, I'm going to use a line symbol above it. This means that it's a line. Line CD is the perpendicular bisector of, in this case, segment AB. I'm going to squeeze it onto my page right here. And notice when I write my segment symbol, I don't put arrows on it. And this little symbol means segment. So literally, if I were to read this with all my shortcuts, I would read this as line CD is the perpendicular bisector of segment AB. So this means several things. One, it splits AB in half into two congruent parts. Let's mark that intersection point where CD goes through AB as M. So you might remember from another course, M is a midpoint. If it is splitting my segment in half, it's the middle of my segment. I'm going to mark this with a single tick mark and a single tick mark to show that AM is equal to MB or BM. It doesn't matter which way you label your letters. They're the same size. So this is a perpendicular bisector. Let's try this one more time. So I'm going to move my paper up and I'm going to create a new segment. So this time, draw a point P and some distance away, draw a point Q. Let's join them to create segment PQ. So if this was a construction problem, my problem would probably say to construct the perpendicular bisector of PQ. So let's do that. We're going to do the same steps above, except I'm going to insert a P and a Q in as I read my instructions. So step one is to construct circle P with radius PQ. So let's put our pointer on P and let's put our pencil then on Q. So we've got to set our radius. So now I'm going to construct step one. It's going to be a circle at P with radius PQ. Awesome. Now let's do step two up above. Step two says to construct, in this case, it's going to be circle Q. So pointer on Q and pencil on P. If your compass is moved, you're going to have to reset them, but mine looks pretty good. So now my pointer's on Q, my pencil's on P. Actually, I'm going to make mine just a little bit smaller. And now I'm going to draw my circle Q. These are two congruent circles that I just drew. So step three, I'm going to mark my intersection points. You can label them anything you want. I'm going to label it R and S. And then I'm going to get a different color because this is now the answer to my problem. The answer to my problem is this pink line or segment if you're going to stop it at the two intersection points. This pink line is my answer. That's the perpendicular bisector of PQ. Everything in pencil was just my work. It's like my construction. So in this problem, line RS is the perpendicular bisector of my segment PQ. RS is my answer. That's the construction that I'm supposed to do. So my pink line is super important. So I'm now going to draw some points on my pink line. Find some point and label it A. Find another point anywhere else. Let's label it B. And let's draw in some dotted lines, dashed lines very carefully. Let's join A to P. Let's join A to Q. Let's join B to Q. And let's join B to P. So any point on my perpendicular bisector, please start writing, any point on the perpendicular bisector, notice my abbreviation, is equidistant distant is one word. It literally means equal distance to each endpoint. This is really important for lesson 3. So what does this mean for me? This means mark a single tick mark in PA and a single tick mark in AQ. This means, for instance, that PA is equal in length to AQ. Now, let's use 2 tick marks in PB and 2 tick marks in PQ to show they're the same distance. So PB, and I could write BP, it doesn't matter, order's not important. BQ. They're the same distance. Okay, you guys, I'm going to grab a different color. Let's connect R to P. And let's connect R to Q. These 2 green lines are also equal distance. So I'm going to put 3 tick marks to show that they're the same. They go together. And so I know that PR is equal to RQ. So all of these distances were the same. Any point, R, A, B, S, any other point on the perpendicular bisector, that's my pink line, is equal distant to my 2 endpoints. In this problem, that's my P and Q. And you're going to use that in some of your practice problems. Thank you very much.